New at 10, did you know the Newberry volcano just south of Bend is home to a groundbreaking research project? Its mission to tap into the Earth itself and deliver clean, reliable, and abundant energy. The project is focused on the use of enhanced geothermal energy, and tonight in our exclusive segment of Shifting Seasons, we sit down with the project leaders to discuss the science, the results, and the potential of enhanced geothermal energy.
Geothermal energy has been explored for several years as a source of clean energy. But the problem is, you have to be in a location that can provide easy access to the heat and water just below the surface. That's what will allow you to produce electricity. But not everyone has Old Faithful in their backyard. But Central Oregon has the Newberry project in our backyard. The Newberry project is a test site with highly advanced drilling processes and other new technologies to make the dream of converting heat from the earth into a clean form of energy a reality. Here's how it works. You drill down to a depth of about 3 to 6 miles, then move laterally through the rocks. Create a labyrinth of small capillaries so you can establish a reservoir of water that will be easily heated by the superhot rocks at that depth. Extract the hot water from the reservoir to the surface and generate electricity using a steam turbine. A new drill called the Mazama drill can get us down to the proper depth and then turn left. A revolutionary new technique called the thermal lattice allows a large amount of water to be collected and heated by the superhot rock for extraction and production. Keeping the water flowing was a big hurdle. Gabriel Grubach, senior completion engineer with Mazama Energy, explains the advancement.
And so the biggest challenge for that in the past history was, and what we learned from oil and gas, is how do you maintain that open enough to sustain flow? We have, vetted in the lab, tested in the field, and we've seen an improvement in the ability to sustain that flow. And always the biggest focus for me as a completion engineer, and I was kind of going back and forth with Alain and the team, is how long can you sustain the flow? And that is why we took the oil and gas world. I might be a little biased, we made it better.
That technology, borrowed from the oil and gas industry, then improved by Mazama, has made it possible to keep the flow of water open and the project alive. Once you have a sustainable flow of water that will last, you have the ability to produce electricity almost anywhere in the world. Don't expect the Newberry project to be a power plant here in Central Oregon. Alain Bonville, chief geoscientist at Mazama, tells us why Newberry, why here, and what is next.
This is a demonstration. This is a pilot. We want to prove that we have a technology able to develop a reservoir. The next step will be to go to the commercial project. But what we have done so far is not a commercial project.
The beauty of the Newberry location is that the research can be done at a relatively shallow depth due to the volcano. But once the technology is proven here, there are much larger goals.
The goal is to deploy that everywhere where you don't have permeability and where you don't have water.
In other words, once this technology is proven to produce energy here at Newberry, it can be used over a large percentage of the United States and the world.
We are developing a clean energy here. What does it mean in terms? It means that we are developing an energy, a source of energy, a source of electricity that will not emit any CO2, and that will be a base load, 24 hours, 7 days a week, 52 weeks a year. So this is different from solar and wind.
What was thought impossible, it's starting to show that it could be possible.
The footprint of a geothermal plant is much smaller than solar or wind, produces energy at a lower cost, and is much less impactful on the environment. The Newberry project may very well be the way of the future as far as clean energy is concerned. And it all started right here in Central Oregon.